Hey everybody, here's another video on file handling, Codio module. I'm just going to go through some of the stuff and hopefully help out. So first thing, files, right? We all know what files are, we use them every day. In this class, we will be using mostly text files for the challenges. Actually, not mostly, we will be using text files for the challenges. But files can be anything, right? Word docs, cell files, videos, pictures, MP3s, things like that. So we'll skip these experiments. File names, right? You can have file names, but the more important thing is that the file names used by Codio don't start with C:, they don't start with slash or //. These are all, if you're trying to get somewhere kind of an absolute location, but files we deal with, at least in these examples, are relative. So they're relative to the actual code file, this file description. So for example, if you went here to project, I don't know if you could see this. Where is it? File, view, I believe, file tree. There it is. You can actually see that your file, file descriptor.py, exists somewhere in here, probably in challenges, maybe content. Yeah, here it is, file descriptor.py. And then this goes for content, text files, parrot.txt. So that's content, text files, parrot.txt. So all these are relative to the base folder here in Codio. So just a little behind the scenes magic there. A lot of this stuff is not too important. The real key here is that you have some sort of path, which is a string. You can open the file and then you can close the file. So that's really the key here. You can do some other stuff, you can get file descriptors, all that good stuff, but really the key that you guys need is you need to open it, you need to open it for writing with an R, reading with an R, or writing with a W. So let's move on and talk about more stuff. So you open it, you close it, all that great stuff. So text files, that's what we're going to deal with. Text files come in a bunch of different formats, but you don't need to memorize them, okay? It's not a big deal. Text files used in Codio are going to have just normal stuff that you could type with your keyboard, like letters, some symbols, things like that. So nothing crazy. So here's a quick example. We have a file path. We open the file for reading with an R. We read the file into a variable. This variable is data. And let's run it. What happens? When we print out data, it prints out the contents of that file. Again, let's see that file. It was in content, text files, parrot.txt. This is the file. This parrot is no more. It has ceased to be. It's expired and gone to meet its maker. I hope you recognize that. But that's from Monty Python, right? So that's what it did. It printed out everything that was in that file. That's all it did. Okay, but here's the key. This data is an actual, it's just a really long string. It's a string with new lines and all that other good stuff, but it's just a really long string. So you can do stuff to this that you would normally do to a string. And one of the key things, and I'm going to move over to something called PyCharm. Actually, sorry, I'm going to copy and paste this because I'm going to copy that, except I'm going to change my file path to a file I have on my computer. But I have this testfile.py, and I'm going to put that in there. And then I have this input file.txt. It's some lyrics from the song Rapper's Delight. But I'm gonna change my file path to be input file.txt. I'm gonna open it for reading. I'm gonna put a space here. You should have spaces on either side of your equal signs like this. And I'm gonna run it. So the same thing should happen that happened before, but of course it's a different file now, right? It prints everything out. But there's some interesting things you can do. So Python has this thing called slicing. You can get little sections of your file. So here I get from 0 up to 7, right? Not up to the 8th position, but 0, 1, 2, 3, 4, 5, 6, 7, those characters. So it actually turns out to be 8 characters because the 0 is one of them, and then character 1, character 2, character 3, all the way up through character 7. But it does not include the 8th position. So let's just run this real quick. What it did is it took characters out of here. And maybe there's a space in there, maybe not, I don't know. So I usually do stuff like this. I put little less thans and greater thans so I know exactly where it stops. Okay, so let's see. I run it. There we go. So what did it do? Character 0, 1, 2, 3, 4, 5, 6, 7. And it does not include the 8th character, all right, which is really the 9th, right? Position 8. Yeah, so that's what you can do. You can slice it, right? I could slice it and just get 2 through 8, right? Again, not including 8, right? So that's that. You can get real fancy with this. Like if I want the last 8 characters, I do this. It looks like an emoji, actually, but if I want the last 8 characters, what can I do? I do that all the way up to -8. So, sorry, I'm not getting the last 8 characters. I'm getting up to, but not including the last 8 characters, right? So there's a bunch of fancy stuff you can do with this. A great thing to do is to you can Google and get quite a few examples. So slicing, right? So Python string slicing. Sometimes the hard part is figuring out exactly what to call it or what to search for. So if you Google that, you can find some great, learning how things are indexed and then slicing, figuring out how to get fancy. Okay, so that's that. So let's go back to Codio and see what happened. So we read this file. Again, the moral of that whole story was this file is now in data, and data is just this really long string that holds everything in the file. That's it. It's not too bad. So let's just do the first one, okay? What do they want us to do? They said you'll be passed a file path P and a string S. Output the number of times string S appears in the file P. So I'm just going to get you started on this, but guess what? Copy and paste. Let's go back to this. Boom. I'm just going to read in the file. I'm going to copy and paste this stuff because I got to do the same thing, right? I got to open the file, but I don't have file path anymore. What do I have? They told us you will be passed a file path P. So instead of this file path variable, I have a variable P. It opens the file. The file is opened as file1. So file1 is like the file descriptor that we talked about before. Then we read the file, but all we're doing is taking everything in the file and putting it in data, and then we're going to print it out. That's not what the challenge wants us to do. But yeah, they expected 0. Our program output, they don't have anything, but really we did print out the data. So I could even do this, just print out, 70 or something like that, right? That's wrong, of course, right? So what we have to do now is we have this data, and we just have to figure out how many times S is in there. Not too bad. Actually, there's a pretty awesome thing in strings called count. And actually, let's not call this count. Let's call this like num bound or something like that. And count counts the number of times a string is in another string. So what we're saying is, how many times is, whenever I put in the parentheses, how many times is that in data? Well, what are we looking for? This says number of times the string S appears, and they read in S up here. So we want to know how many times S is in data. Well, if I run it, what happens? I don't get any syntax errors, but notice I'm just printing out 70. So let me fix that. I probably want to print out num bound, and then let's see what happens. Wow. Now, again, I mentioned this before, but notice what happened. Your output was 3, but we were supposed to get 0. What happened? Well, what happened was there are multiple test cases being run against your code. So we failed the first one. When we just printed out 70, it wanted us to print out 0. Why? Because it passed in, notice the file it passed in, empty.txt, and it's looking for parrot. Well, I'm assuming, I should never assume, but I'm assuming that empty.txt doesn't have anything in it. And so if I look for parrot in this empty file, I should find it 0 times. So when I fix my code back, and I pass, notice the different input. The input is parrot.txt. So there's another file that has the word parrot in it, probably. It actually has it 3 times. And we passed that test case. And we probably passed the 0, 1, 2, but it only shows you the last one you pass. Okay, so that's that. Let's see what else we got. Writing a text file. So what do? If we want to write a text file, we open it again, but we open it with a W there. Okay. So what the W is it says we can write, right? So we're able to do what we need to do. I'll let you go through this, but in general, that's all that's going on here, is that you're writing it out. So let's see. So challenge writing a text file. You'll have to do that. You return the contents of it. You can see some of the solution here, but yeah, so that's that. Writing a text file. That should be reasonably easy. You have a path for input, I, path for output, O. So you're going to open up 2 different files, and then you have a string S and a string T. All right, so you read the contents of I, so you open up I, you find every S, you put T in there instead, and then you write it out to O. That's an O, not a 0. Okay. So that's that one. Let's see here. Data formats, right? So sometimes the data is organized in certain ways. They have extensions, all that type of stuff. It's not, you don't have to deal with this too much. Okay. Now they talk about fixed length records. So pay attention to this. This is very important. They're going through the idea, and just to clarify, this file that they're going to be using, the first name is going to be 16 characters. It's going to be whatever the name is followed by spaces. They put underscores to kind of show you what the space is, but that's that. And then Smith has 16 characters too, but it's Smith with spaces to make it 16. But then the confusing thing is the date of birth right here only has 8 characters. Okay, so they're just telling you that's how the file is organized. Okay, they also said that there's no new line characters. Okay, this is how they've formatted a file. It is what it is, but it's not any standard format or anything fancy like that. That's just how they did it. And in fact, I bet you, if we do a little snooping, we can find the actual file here. Let's see, challenges, no content, text files, fixed length. So see, this is what it really looks like. It's Adam with some spaces. Again, this is 16 characters. Smith, 16 characters, and then 8 characters for the birthday. And then they go right into the next name. Theodore Anderson, birthday. Monty, with spaces, and then Biscuit Barrel with spaces. And so I'm gonna notice it's just a big long string. Okay, so they're showing it to you this way, but really it's one big long string. So why is that important? Well, you pretty much have to deal with this file type, this file format over here. Okay, so now they're going to pass you a file path P. You'll have to open the file. The first name is just going to be a straight up first name like Adam. Okay, right here. No spaces, nothing, just Adam. And then Smith, and then, like a birthday. That's all they're doing. Okay, so it's file path, first name, last name, birthday. What do they want you to do? They're going to ask you to do some crazy stuff, right? So you pass in this file name, first name, last name, and birthday. And what they want you to do is load the file, look for F and L, and try to find, basically, that you got to find that first name and that last name. And then for that first name, last name, replace the birthday with whatever B is when it's passed in. So again, let's go back to that file tree. Let's look at this file. So for example, if we look at this challenge, their input, it's a file name, but don't worry about that. They passed in Adam, Smith, and then all that stuff. Okay, that's what they pass in, and they want you to replace whatever Adam Smith's birthday is with this new birthday. So what they want you to do is go through, find Adam Smith, which he's first, he happens to be, and then notice his birthday is 11/11/1985. They want you to replace it with 11/11/1900. It's a very old person. So that's the goal, is to go through this file, find those names, and replace. That's it. That's about all you need to do. But it's hard. It's hard to do. So again, just yep, I still had it. So you kind of paste it here, open the file, but you want to open it P, right? File path. read in the data, and then notice at the end they said, then save the file. We're replacing it. We got to write that file back out. And so what I would recommend you do, don't print out the contents. Okay, just close the file. Do all your stuff that you're going to do. And then you would do something like maybe file1 dot open. Same file path, but we're going to open it for writing. And then we do file1 dot write data. I misspelled write. Data, and then file1 dot close. Okay, and let's just check it real quick. All right, had a problem with something. What did I do wrong? It has no attribute open. What am I doing wrong? Oh yeah, duh. Sorry guys. File1 equals open pw, right? Not file1 dot. Okay, so my output did not match the expected output. And that's fine. As I didn't do anything, right? All I did was open the file, read it into a string, and then close it. Okay. So what am I going to do? Well, this is going to be up to you. But what I would recommend, there's a few different ways to do this. Different people have done it different ways. But the way Codio is looking for you to do is just to have you read it a few characters at a time. So my recommendation is a while loop. Okay. And you probably want a some sort of index, right? And you probably want some while loop, and you would probably say while index is less than lang data. And then what we're going to do is we're going to read in the, let's just start out by reading in the first name. So first name equals, and we're going to read in everything in data from our index up to index plus 16. Why did I do plus 16? Because they told us that the first name was 16 characters long. Our last name is going to be data, and then probably index plus 16, all the way up to maybe index plus 32. Okay, so that's our first name and our last name. And then our birthday is going to be data index plus 32, all the way up to index plus 40. Why did I only go up 8 this time? See, I went from 32 to 40. The reason being because that birthday is only 8 characters long. And then what we can do is we can say index plus equals 40. What that'll do is the next time we loop around, this index will be at 40 instead of 0. So it'll be 40 to 46, 46 to 72, and then 72 all up to 80, and so on. So I'm going to stop there. I'm going to let you do the magic, but do something here. You're going to have to do something there to actually change things, right? you're probably going to want to check the first name and last name against F and L. And then if it matches, you want to replace the birthday. So you're going to have to change the data to be a different birthday. And then you write out that data at the end. So again, let's check it. We're going to get the wrong answer. We know we're going to get the wrong answer, right? But it doesn't matter because we didn't get a syntax error. So that's the key there, okay? All right. Well, thanks everyone. Thanks for watching this video, and I hope it helped out. I'm gonna let you do the other ones. The other ones are harder, but again, please just email if you need help. Just let me know. All right. Thanks everyone. All right.